want AI to identify where you breathe, eat, sleep, your political views, all that. And they're like, whoa, that's not what I want. I just want to catch bad guys.
The success of AI is the success of data. Good data in, good data out. Junk in, junk out. It's no different from any other system.
My research is directly related to trying to find ways where we can capture all of this data to improve and enhance performance, right? But my colleagues at the laboratory are always asking, where's the protection? If you can use it for good, you can use it for evil.
We want to use AI to say, what is the best treatment for this specific patient?
You draw the wrong correlations, people's lives are impacted.
And artificial intelligence is just as prone to bias as any other intelligence.
Put the privacy and the legal folks at the forefront. And what you tell them is, these are my requirements. Where do you see the privacy implications? Where do you see the problems with conflicting statutes, with conflicting regulations?
Amongst risks and opportunities and rewards and fears and threats, it is inevitability. There's not a single federal agency and probably not a single federal program that could not benefit today from some minor application of it. Every step we take and one agency takes, it is opening up a whole world of improved services and cost savings for agencies.
All right. Hello, welcome to CXO Tech Forum on AI and Big Data in Government. Thank you so much for joining us this morning. My name is Michael Hoffman. I'm the president of GovernmentCIO Media and Research. We're so happy you joined us this morning. What a beautiful morning we got with the sunrise. It's gorgeous. And what we're really excited for the agenda and the speakers that we have today. So GovernmentCIO Media and Research is an online destination for thought, leadership, and coverage within the space of advancing technologies and management landscape. So our team is out here today. Hopefully you got a chance to meet them during the breakfast part and got to talk a little bit with them. It's been a really good time getting to know a lot of the folks here from like Army Futures Command. We have folks from CMS, healthcare.gov. What a great collection of government folks within this AI space. AI is such an exciting topic right now. It's something that everybody is talking about, everybody's wondering about, wanting to learn about. So what we tried to do is really put together a group of speakers that come from all spaces: Army Research Lab, HHS, Johns Hopkins, Cloudera, Worldwide Technology, all these different spaces where there really is a real leadership. Lumina Analytics, another one, that are really the thought leaders in this space and can really teach government and really help government really take advantage of this advancing technology. So first, before we move on to the program, I really wanted to thank our sponsors. Without doing this, anybody that's done these events before knows that you can't really do these events, especially at such great venues like this, without our sponsors. So I wanted to thank Lumina Analytics, Worldwide Technology, Intel, Cloudera, MicroStrategy, Qualtrics, and Penguin Computing. Everybody, all of those sponsors really had a really important part in making this morning happen. So, round of applause. Thank you very much. So without further ado, I want to really bring forward our first session. We have a packed lineup today, so I want to get them up here. We know your time is valuable, so so what we want to do when we are putting together this group of speakers is, again, we wanted to have the thought leaders, the experts in this area. And when you ask anybody within the Defense Department or the Pentagon, which you can see right over yonder here, everyone brings up the name Dr. Alexander Kott. They say, hey, he's Mr. AI. He's the one you needed to get on the stage and talk about what is going on within artificial intelligence. And he's really working on the investments in terms of research for the Army Research Laboratory. So what we want to do is invite him, as well as Molly Kane, who is the former Director of Ventures and Innovation with Department of Homeland Security. And what we're really excited to announce this morning is, should we do it, Molly? Or should we wait? We can do it? We can do it? All right. So Molly will be our next host of our podcast on GovernmentCIO Media. We're really excited to have her do it, and we're hoping everybody got a chance to see some of our other podcasts, such as Cybercast and GovCast, and we're really excited to have her as the next one. So let me introduce Molly, as well as Dr. Kott, onto the stage, and we'll go from there. There you go.
Can you hear me? All right.
We're on. Okay. All right. Dr. Cott or Alexander?
Alex.
Or Alex?
Let's do Alex.
Wonderful. Okay. So thank you for being here. We'll get into a little bit about your career. We've had some really interesting discussions already this morning, so I'm excited to share that with everybody. Again, I'm Molly Kane, and I am not the AI expert, so I'm going to dig into your brain. So everyone here...
Be careful.
Prepare yourselves. So everyone here has a wide variety of awareness and knowledge about AI. Who here feels like they are also an expert in AI? Okay, so we have that assessment.
Okay, we're all on the same level. Great.
Perfect. We're all going somewhere. Okay, so there are vendors here in the room that want to work with Army research laboratories. There are federal employees who may be working in AI or may wish to or don't understand what careers of the future there are available. And there's everything in between. So give us a unifier to start the discussion and tell us your, I don't know if I want you to define AI, but give it a whirl.
I don't want to define AI. There was so many people, very bright people trying to do it before, and I'm not going to succeed where they failed. One big problem with AI, of course, is that as soon as it works, people say it's a problem of receding horizon. You read about it probably. As soon as it works, people say it's not AI, it's just an algorithm. I was told that in 1960s there was a joke: if it works, it's pattern recognition. If it doesn't, it's AI. We live in a really amazing time. Back in 1970s, 1980s, hundreds of PhD dissertations were written about how to find a route on a map with complex traffic, with closures on the map, and so on. This was PhD dissertation after PhD dissertation. It was a major problem in AI. Today, you're using this AI every day on your GPS app. You have no idea that it has inside of it routing algorithms that are derived from that work on AI. And you don't need any education in AI. You don't need to know that it is AI. You are just turning left, you're turning right where you're being told, and you're good. You are listening to AI. Think about it. Think about it. 20 years ago, to assume that you will be following the directions of an AI machine would be science fiction. Even right now it sounds a little bit like science fiction, but you're doing it every day. Alexa, can you please turn on this such and such music? You're doing it every day. This is interesting. This is an amazing time that we live in.
So you've just told us all that probably part of our work days there's AI involved. So are we all AI workers?
And wow, that again, another definition. What is an AI worker? There are very few of us who are actually truly working on AI. Most of us are and should be working on how we can apply the best available technology to the mission of our organizations. I hear too much of talk about, oh, what can we do with AI? Ask not what you can do with AI.
Someone please tweet that.
Ask what AI can do for the mission of your organization.
So you've been quoted as calling, well, so you did mention buzzword. We all know that from politicals to all of us, we use AI even if we're not really aware of what it completely can be used for or is in use right now. Would you call that irrational exuberance?
Yes, I did call it irrational exuberance, and it is, you know, we do disservice to AI. I love AI. I was bitten by the AI bug back in 1980s and mid-1980s and was working on it on and off all these years. It is a wonderful area of computer science and beyond computer science. It has done a lot of useful things and will do amazing things. But irrational exuberance, over expectations, overselling, boosterism, all this does no good for the progress of that field. So let's not be the part of the snake oil seller crowd for AI. Let's be realistic about AI. Let's focus on what it can do for the specific tasks, specific missions of your organization. If it's appropriate, it's appropriate. If it's not appropriate, don't sell it. Certainly don't oversell it. Too much of it is going on, and it usually leads to yet another AI winter. Many winters ago, I started looking into that. Many AI winters, I started to looking into that. And so let's not do that.
So you've been working on it since the mid-'80s. Clearly, you don't think this is a fad. It's not new. It's been around. So how do you feel right now as all of us, like these kinds of events weren't happening back then. People like me weren't interested in AI until quite recently. So are you excited about this trend? Are you excited about it being a big buzzword, or do you have warnings for us?
You know, I'm a bit anxious. I'm afraid that there will be yet another wave of disappointment and people are saying, oh, this doesn't work, it's just a bunch of buzzwords, and they will switch attention to something else. I would like to have steady, non-exuberant attention to AI and its use in practical good work that all of your organizations need. Rather than talk about AI, we really need to work on AI with less words. You know, look at this room. How many hundreds of person hours will be spent here this morning? All of you are paid, right? You all have salaries, right? If all this money were put together and invested into actually developing a practical AI application, that would perhaps be better than us talking about AI. Just a thought, just a thought. I'm not suggesting you need to leave this room.
At least stay for the rest of our talk. Okay, so to that point, how should everyone in this room be spending time caring about AI? When they leave today, what do you want them to know? How do you want them to contribute to Army research laboratories, for instance?
Those who want to give me business cards after this event are certainly welcome to do so. I will try to do what I can do. We, by the way, we at the Army Research Laboratory, we are very actively pursuing a business model called Open Campus. We invite organizations of all kinds, government, academia, industry, international, to work with us through CRADAs, collaborative research and development agreements, and so on. We have hundreds and hundreds of these CRADAs, and many of them are very productive. So if you're interested in something like that, please talk to me. Some of this work is in the AI world, so this is very useful. How would I suggest that you approach AI is, as I already mentioned, take a look at what tasks you may need or may want to automate in your organization. If it is not something that you want to automate, AI is not going to help very much. If it is already being attempted to be automated, you probably need to ask yourself, why did it fail before? AI is not a magic pixie dust that you can sprinkle on your problem and it suddenly will get solved. It is not. So ask yourself why it failed before and why would it succeed now if you apply AI. AI is not a magic word that you can simply pronounce and it will happen. And then look at the available tools. There's so many excellent tools already available out there. You can apply them. You should talk to vendors. You should be very hard-nosed and skeptical when you're talking to vendors. I was one of those vendors back in 1980s, early 90s, and I know that people who talk to me should have been more hard-nosed and ask more difficult questions. So please do that.
So, okay, let's dig into that a little bit more. Who here is a federal employee? Or, oh, awesome. Who here?
So you didn't pay, right?
Hopefully not. How can they are getting pitched, regardless of level, role, budget capability, anything. They're getting pitched every time they're outside on AI solutions and technology. And there are probably some great solutions and technologies and folks selling products right now in this room. So how can that relationship be successful? What should a federal employee, a government employee, or someone who's purchasing those solutions know from a due diligence perspective without having to deep dive into AI? Give them a couple of questions that they should ask to expose the snake oil.
Well, the obvious question is, why do you call this AI? Most vendors have difficult time answering why they call their product AI. Overwhelming majority of what's under the hood of their product is old, good IT and the statistical analysis. And that is perfectly okay. If it does the work for your problem, it's perfectly okay. You know, there is in every successful solution, there is an ounce of AI inspiration and tons of conventional IT perspiration. You probably need to know that, and if it's conventional IT and it solves your problem, very good. Don't resist. Don't refuse to take yes for an answer. So AI is very often not the best solution, and therefore ask very hard question about what's the AI there and why it needs to be there. You will be surprised at the answer, or more often lack of an answer.
So in researching for our conversation, we all remember when Mark Zuckerberg was chatting with the technologically challenged folks. We won't name names. He mentioned AI 7 times unprompted, and I know that there was a variety of understanding in that room, and there's a variety of understanding or misunderstanding in leadership today, the guys who have to make the decisions, the men and women. So how do we talk to our leaders about AI, or vice versa? How does the leader start to make decisions around it? Should they be?
AI is interesting in that it elicits amazingly irrational responses. This is the first time when we're facing something that actually exhibits intelligence that is so similar to our own. It's like we're looking in the mirror and we're afraid at what we're seeing there. We don't like what we're seeing there. It's not nearly as beautiful as we thought. So people talk strange things about AI. People talk about, well, AI will destroy the world. Serious people, captains of our industry are spouting this kind of things, which I personally do not believe at all. At the same time, we do need to recognize that this is a revolution in technology, and it is a revolution perhaps in the human existence as a whole, because this is the first time ever that not the physical existence, some physical aspect of our existence being automated or assisted, like steam power or gunpowder and so on. This is the first time in human history that we are being assisted in our thinking, in our intellectual activities. This is unique. This never happened before. This is amazing. So that is going to be revolutionary. So there are two sides to this. One, let's not over-exaggerate. On the other hand, it is revolutionary.
So pulling that thread a little bit more, we had a great conversation earlier. There's a historical resistance to anything that drives change. Can I get you to go a little bit around that conversation that we just had? You mentioned steam power. So we've seen this situation before, not necessarily with something so advanced, but talk about the historical background of this resistance and what we're experiencing now.
So steam power is a bit of an analogy. Between 1820 and 1870, the United States have undergone this dramatic transformation in many, many respects, economic, social, and so on. And it was driven to a large extent by steam power, by the availability of steamboats and steam engines for the factories and, of course, the railroads. This was an enormous transformative force for this country. And it was assisted, fortunately, by fairly sane and reasonable actions of the governments, local governments, communities, federal government, who had to institute some laws, who had to put some sanity into that whole process, had to govern it somehow, regulate it somehow, and they did a remarkably good job about it. It's worth looking into that. It's worth seeing this as an example of a sort. And remember, this was done in face of all kind of fears and scary expectations. Oh, you know, those railroads, they will kill people, they will kill cows, they will take away land from people, nobody will be able to get from point A to point B. They move at such high speed that people will actually be unable to breathe. There was a scientific argument of that sort, no kidding. And all this was overcome. This is an interesting example of perhaps how we need to deal with AI.
Okay, so I do a lot of Molly pro sports opinions, so I'm going to throw one at you. I have a theory that the conversation about our workers today being scared of AI taking their jobs is not really what they're saying. Do you agree or disagree?
I don't see that, frankly. You know, the people who may feel the most immediate threat would be truck drivers, right? Truck drivers. And even they, I don't think, exhibiting any particular fear of that. They realize fully that this actually will be very probably helpful to the trucking industry. And there will be more jobs in trucking industry, maybe of different kinds. Maybe they will not be drivers of 18-wheelers. Maybe they will be dispatchers. There will be something else. There will be different jobs available. Every spiral in technological evolution brings a lot more jobs than it kills. And that's historically true. So I think most people understand that. I don't believe there is a lot of fear out there. I think we talk about it more than we need to talk about it. Ethics and related issues of how societal changes occur is very much an empirical science. Let's try it and see what happens. A lot of things will happen regardless of whether we try or not. It will just emerge and happen, and we will be there regardless of what we do about it.
So on the ethical conversation, and we'll get into it a little bit more probably on the podcast if you join me, but on the ethical element, I had a great conversation with somebody recently who said that anybody who really is getting into AI and developing it and influencing the direction of it needs to wake up on Monday mornings with the accountability level, not of the work that they're doing for their company, for their day, for that particular mission need, but contribute to the greater good overall. So you've been doing this since the 80s. I kind of sense that you have taken that approach. Do you advise that of others as well?
I'm afraid of people looking at horizons that are much broader than they can actually influence. Look, on Monday morning, we have to come to work and answer 200 emails, and that's what we do, right? Let's focus on those 200 emails and what we can do better than those 200 emails. We all contribute to the well-being of society, and we do it at a local level. We'll do it by focusing on our jobs and doing them the best way possible. The bigger thoughts we think, the less results we might be able to obtain, frankly.
So it's not as big as and scary as some people are having this conversation. It can still be on our granular level with our
Very much so. On our granular level, we can affect a lot of positive things. And I should tell you, when you think about AI, remember, all AI is wrong, some is useful.
That was an excellent talk point there. So let's see. Do we have the workforce now to be developing AI? Should we be hitting up all the high schoolers that don't want to go to college and want to go immediately to Army research or to a startup, become a billionaire? You know, it's so easy.
I see a lot more kids who want to become billionaire than working at the Army Research Laboratory.
How do we make it sexy again to do the R&D, the S&T in the government to that point right there? How do you drive them away from becoming a YouTube influencer and telling us all how to put our makeup on right?
Yeah,
me, not you. You're not. Personal problem.
I hear a lot of questions about how do we attract the best and the brightest into the federal workforce. This is a legitimate concern. We do experience a lot of market competition, and in some hot fields we really do, see almost inability to attract some of the important demographics. At the same time, if you focus on the uniqueness of your mission, you usually find people who will love that particular mission, which will appreciate the beauty and importance of it. So, for example, when people come to the Army Research Laboratory, we talk about the opportunity of doing amazing science, science that can influence a lot of lives, which can save soldier lives, science that is going to make or break the future greatness of this country. And which will be tremendously cool and interesting to do for them personally. And we do find that fraction of young individuals, usually young, who recently got their PhDs in science, technology, engineering, math, and so on. And that group loves it. They love it to work for us. They enjoy working for us. We enjoy working with them. These are the right people. There are other people who are looking for something else, and they are not the right people for our organization. You will find the same probably phenomenon in every organization. Every organization has some unique beauty of their mission, and you can communicate the beauty of that mission to those people you're trying to recruit, and it works.
Well, and I know I've spent a lot of time lately with some high schoolers mentoring them, and I believe that they're pursuing entrepreneurial ventures not to become billionaires, but to put their imprint on the world in a much more mission-driven way, and they feel like designing their own company is the way to do that. So if you were to speak to them today, why should they come work for you, and do they get to get their hands dirty? How do how would they spend their day at ARL?
Look, if a young person comes to me and says, I want to do a startup, I have an idea. Should I go and work for the federal government, or should I do a startup? I say, go and do startup, honestly. This country is built on entrepreneurship. This is the biggest, most beautiful, most powerful force that made this country the great country that it is, entrepreneurship. Private initiative, risk-taking, desire to go ahead and do great things and run your own company. Go and do it. Go try it. When you are ready, give us a call. We would love to work with you. We love to work with startups. We believe that the government of this country is great when it works well with businesses. Big businesses, small businesses. When we're talking about AI, small businesses are wonderful. That's where a lot of innovation, true innovation happens. So let us all, if we work within the federal government or around the federal government, let's be strong supporters of entrepreneurship.
Okay, so while they're getting their training in failure out and doing startup world, although, personal opinion again, what do we do with the existing workforce? We have a lot of demotivated, depressed, 20-year veterans in the federal workspace, and they feel like they just need to be done at 5 p.m. They'll never, can they get excited about AI?
They can.
Not everyone's depressed.
They can. Look, I don't think I can add much to a enormous literature and endless number of discussions about how to motivate workforce. But can a new and revolutionary technology like AI to get somebody to wake up and say, hey, I might have a new line in my career. Maybe there is a new beginning, a new dawn. What if I learn some new tools and become very important and well-respected worker in my organization? Yes, that can happen. And in fact, yes, you should try it.
Beyond having conversations like this with me during your morning in lieu of 200 emails, how else do you spend your day? Inquiring minds want to know.
You want to know everything about me. So in the army, soldiers, it is said that soldiers do three things primarily. They move, shoot, communicate. Move, shoot, communicate. So that's what I try to do. I try to move, shoot, communicate. Move means I try to make sure that our organization is moving in the right direction scientifically, technologically, that we are moving in the right direction, pursuing promising approaches and so on. Shoot, that means I need to help our scientists, engineers, researchers to have impact on the outside world, outside of the laboratory. That's what I call shoot. And communicate is, right now is an example of what I do to communicate. I go out and I talk to people.
Okay, so you have only one more question, and you've already given us a lot of words of wisdom, but what can you leave us with today that everybody will walk away a little bit smarter, a little bit wiser about AI?
Focus on the mission. You have a mission. If you don't have a mission, you're in the wrong place altogether. If you do have a mission, focus on it, and that will tell everything you need to know about AI.
Thank you so much, Alex. Appreciate the time.
Thank you.
All right. Well, thank you very much, Molly and Dr. Codd. I appreciate it. Our next piece is going to be myself, and Dr. Morten Middelfart from Lumina Analytics is going to join me to talk a little bit about the work that Lumina does. Lumina is based down in Florida, and we've been lucky enough to learn a little bit about the work that they're doing in terms of the programs for national security, as well as Mission Lisa. So we wanted to take a little bit of time here. So Dr. Middelfart, to my left here, he has an interesting background. He has twin doctorates machine learning as well as managerial science. And one of the interesting parts about Dr. Millefart is he is retired in the Danish Army, where he served as a first lieutenant in the motorized combat infantry. So we're excited to have him join us here. So to kick things off, Morten, why don't we talk a little bit about just a quick intro to Lumina for those learning about them.
Sure. Thank you so much for that introduction and having me, and thanks for listening. Lumina Analytics is an open source intelligence firm, and we work with ingesting massive amounts of data and then cleansing that using algorithms and really crystallizing intelligence that is extremely actionable. For that, of course, we use algorithms, as been said before, because that's AI when it works. But linear algorithms surely also play a part, but mainly a lot of machine learning, because it's an effective way to achieve algorithmic efficiency in that equation. Our mission is really to work with problems that are so big and hard, usually stuff that will either save lives or prevent massive human suffering.
So Lumina Analytics did initially start working with government agencies or national security problems. Could you talk a little bit about what really motivated you? Because I think it was a real local issue, that's close to your heart with what happened there.
Absolutely. We were running these systems for certain corporate risk in the beginning, but then the Orlando shooting happened down in Florida, and we're based in Tampa, so it really hit close to home. So we thought about how can we direct these systems that already work for other types of risk, how can we direct them into see if we can prevent similar situations going forward.
Okay. So speaking of national security, what are some specific problems that your team is addressing through AI with national security?
Well, the overall problem we're addressing is one of speed. Since we're working in the open source intelligence, we have a potential for being extremely fast at detecting patterns, detecting threats as events either unfold or even when somebody's in the planning stages of a malicious event. So using algorithms to sift through that noise is really the most important thing that we do, and effectively we like to say that you want to get left off bang. What that means to me is not just being predictive, because predictive is just expecting the past to repeat itself. It's more like being real time by using these algorithms to highlight the problems that are actually happening here and now. And specifically, we work with problems within counterterrorism, for example, with national security.
Yeah, I mean, there's so much data being collected, especially with social media, whether it be Twitter, Facebook, and whatnot. And I think it's really exciting what the work that you guys are doing in taking all that data and inputting that and analyzing it in such a way that you can really glean information. It's not exactly Minority Report is coming out here, but you never know. I mean, I think it's kind of interesting with what Dr. Kott's doing with Army Research Lab, as he was just talking about, and some of the other, we're going to talk a little bit with our national security panel next, but I think it's exciting some of the work that you guys are doing in that space. Could you talk a little bit more about what you're doing with some of that social media data?
Yeah, I want to stress, first of all, it's not Minority Report, because that is predicting.
I don't want to get ahead of it.
We are actually reporting what is actually happening, but really, really fast. Second of all, it's not just social media data, it's everything. It's signal intelligence on the entire internet. It's whatever data is out there, but it's all open source.
Okay.
In general, what we do is we work with a lot of transportation, people traveling international, traveling in transportation systems domestically. We can use this for screening, and we can also use this for screening people in various roles in both corporate and government. So a lot of understanding about what kind of behavior individuals are are doing online. And in addition, we also have unsupervised learning that will uncover if somebody's in the planning stages more discreetly across the, international too.
Okay. So we'll do a little bit of a pivot here to some of the work that you guys are doing within healthcare. Could you talk a little bit about your Mission Lisa program and how you guys are addressing the opioid crisis?
Yeah, it's similar techniques as we're talking about right now. We're also trying to assist with the fighting the opioid crisis. The way you could do that is also look for clusters of trending indicators of opioid addiction. The worst of them, but is probably death from overdose. But also treatment-seeking behavior, understanding where that is trending, clustering, and so forth, will give us a handle on the crisis overall, and also allow us to allocate resources, but most importantly also how those resources should be applied in the given situation when they're on the ground, so to speak, close to the problem.
Okay. So what are some of your top goals with the Mission Lisa program? What are some of the, maybe some of the trends that you've seen, and how are some of the ways that you guys want to address it within Lumina Analytics?
Well, aggressive intervention is probably one of the main thing, and I believe we have a little say in that on the video, that one of the findings we had. But what happens is that people usually don't die from the first overdose. So and that finding means that if we can aggressively intervene after the first overdose, that will significantly increase the saving of lives. And that's probably the most crystal piece of information we've found so far. And that was from machine learning algorithms that we're seeking to optimize within that space.
Okay. So you mentioned the video. We have the video team back here. If we could play that, it gives an interesting discussion here on the opioid crisis, and talk a little bit more about the Mission Lisa program.
In 2017, nearly 50,000 people in this country died from opioid-induced overdose. That's 135 people every day. These statistics are alarming, and the people affected are real. Their families, friends, colleagues, communities, our society pay a heavy toll. While we measure the mounting human cost, research shows that the solution lies in strategically deployed machine learning and artificial intelligence. In 2018, Mission Lisa released a policy recommendation outlining an enhanced treatment intervention program to reduce the nationwide number of opioid overdose deaths by 41 to 58%, saving between 56 and 78 lives every day. Nearly 90% of opioid overdoses do not result in death, and those who survive are at significantly increased risk of dying from a subsequent overdose. Mission Lisa seeks to break this cycle and save lives by addressing the gaps in emergency care for victims of non-fatal overdoses. Traditionally, those experiencing an opioid overdose are transported to an emergency department after receiving naloxone and are observed for 4 to 8 hours following the incident. Many victims experience immediate withdrawal symptoms and turn to additional opioids to relieve physical and emotional distress, increasing the risk of rapid recurrent overdose. Mission Lisa's Enhanced Treatment Intervention Program recommends EMS transport of all opioid overdose victims to an ER, inpatient care and observation for a full 24-hour period, education from nurses and nurse practitioners on the risk of death from repeat overdose and the availability of treatment options for addiction, introduction to a voluntary medication-assisted treatment prescription program and long-term behavioral therapy, and the release of naloxone to the patient and family members or friends who may be present in the event of an overdose emergency. Please join us in our mission to rapidly reduce opioid-induced mortality. Help us save up to 78 lives every day.
All right. Well, that's perfect. So thank you so much for joining us, Dr. Milpart. It was great to learn a little bit more about what you guys are doing with Mission Lisa, as well as your work within national security. So thank you very much. Could get a round of applause for Dr. Milpart. Thank you.
Thank you so much.
All right. Well, I think that's that too is I believe, a perfect transition here to our healthcare panel, where opioid crisis will be one of the many topics that we are discussing. So, Amanda, could you join me? Are we going to go with national security first? What? Oh, Aaron, excuse me. Aaron, my fault. We will have Aaron, please join me. My apologies. Aaron, come on up and join us. So, yep, we'll just start right here, and then we will grab a microphone for you. Oh, just right there. We need a microphone. We need a microphone? Stop. We need a microphone. Do we have one? Do we have 5? All right. Do we have it?
Yeah, I think so. Well, maybe not. Maybe we do. I don't know.
Where? Oh. Do we have one?
Hello?
And Aaron. So we have Erin Mirsky, who is our VP for digital. She is going to be joining us and leading the healthcare panel. So sorry for the confusion right there, but we'll kick it off here, and she's going to do a great job. Thanks.
Good morning, everyone. I'm Erin Mirsky, and I'm Vice President for Digital Services at GovernmentCIO. And for the next 30 minutes, our panel will address questions and discuss progress they're seeing related to artificial intelligence and machine learning supporting the health issues that they're facing today in their organizations. This group is going to be prepared to discuss clinical issues, regulatory science, and some cyber topics. So joining us this morning is Rosalie Bright from the FDA, George Chambers from HHS, Suzanne Palmer from Johns Hopkins University Applied Physics Lab, and Dr. Rucker from ONC. So I spent a little time getting to know each of our panelists, and I'm excited for them to share the efforts that they're supporting. This is a really great group. And since some of you who know me know that I'm a little bit competitive, if you guys would use the hashtag that we have today for CXO Tech Forum, I'd love to see your comments afterwards. Don't be shy. And so now if each of you would briefly describe your role in your organization, and then we'll begin our discussion, followed by time for audience questions.
Hi, so I'm in the Office of the Commissioner, and within that, in the Office of the Chief Scientist, I'm an epidemiologist, and I have my own research project, but I also kind of get an overview of what's going on in the different product centers, and I represent FDA on the Federal Health IT Research and Development Interagency Working Group.
Great, and thank you for inviting me. George Chambers. I'm Deputy CIO for HHS. That's the corporate side of the house. So we're represented by ONC and FDA, which is great. Thank you, both colleagues, for being here. I have responsibility on the operations side, so I may be a sort of an outlier in this group. I manage the corporate network as well as all the seats for the Office of the Secretary in headquarters, which is about 12,000 seats. We take care of all their infrastructure. And we also have support for cybersecurity and other aspects. So I'll be bringing a different slant to the conversation.
Good morning. I'm Suzanne Palmer from the Johns Hopkins Applied Physics Laboratory. And just to make sure I clarify our role in the broader Johns Hopkins organization, of course, we are part of the university, but we're what's known as a university-affiliated research center, which many of you may be familiar with. So our role is really providing trusted, objective, technical support to the government. And we work in areas that span space systems, where we build, deploy, and launch systems that go to Pluto and the Sun, and I oversee our mission focused on health and healthcare. So that's my role at APL.
Okay, Don Rucker, so we're not quite to Pluto. The Office of the National Coordinator is set up to basically encourage electronic medical records. It's a staff agency within Health and Human Services, as George mentioned, and we have sort of a dual role. On the one hand, we are a regulatory body certifying electronic health records, so involved in a lot of the technology stack, just does it work? And on the other hand, we're there, frankly, to encourage the use of these records, and we do a lot of that with CMS.
Great. So just a quick reminder that following this panel, we're going to have time for networking. And so if people in the back could keep the chatter down, because it really does, we can really hear you up here. So it does get hard to hear. And so our first question for you guys, over the last 50 years, AI and healthcare have been a popular topic among researchers. It's not new. And we're currently seeing an AI renaissance. And it's fueled by deep learning algorithms, investments that we're seeing in precision medicine, robotics, imaging, and diagnosis. How is this resurgence different from the past? And how do we avoid some of the trappings? I love the irrational exuberance that Dr. Cott and Molly Kane mentioned. So how is this different? We'll start with you, Dr. Ruckers.
Yeah, so depending on how you look at the perspective of getting older, I had the privilege of being a grad student in the first AI revolution. So I was a grad student in the medical computing group in Stanford's AI lab in the 80s. With my thesis advisor was Ted Shortliff, who invented rule-based expert systems. And I think what's different now, or maybe even in the early 90s, when we had neural nets, I mean, looking at those early projects, you just intuitively knew, while they could certainly solve some problems that hadn't been solved, they were really, in many ways, toy systems, right? If the premise of AI is to be like the brain, right, just the overall premise, and the brain has something 10 to the 10th neurons, 10 to the 13th connections, having a few hundred nodes in a neural network is very unlikely to represent the brain on any level. And so we frankly did not have the resources. I mean, these were the days when we weren't even up to, a meg of memory in the early Windows operating systems. So we were trying to do this on essentially negligible amounts of computing. Today, we have vast amounts of computing. And I think when you look at machine learning, when you look at the algorithms, when you look at the representations, there's just vastly more compute power, and it can give a lot more accuracy in the model. So it's very exciting, and I think we're seeing the performance you would expect. So it's quite exciting.
Yeah, so I completely agree. It's funny, when I entered the workforce, as my kids like to remind me, in the 1900s, it was signal processing, right? And so in the days of signal processing, it was really, in a lot of cases, you had a two-class problem and you were trying to separate signal from noise. I think today, as we look at, of course, the increased compute capacity, but also measurement, and as a result of measurement, the amount of data that we have available. So not only are we able to measure many more things with many different modalities, but we're able to measure it to levels of resolution that we could never achieve before. And so when you look at all the data that's available to us now to use as input into these, whether they're neural nets or different approaches, deep learning for artificial intelligence, I see a huge shift. We're able to ask questions beyond, yes/no questions. Is this a target? Is it not? Is it, disease state? Is it not? But you're able to look across varying complexity and, look at a multi-dimensional state and try to pull out patterns across disparate data sources.
So I'm going to keep moving because so Rosalie, how is big data helping expedite FDA approvals for drug devices, specifically around clinical testing and delivering new cures for pre-certification type programs? And then if George would also talk about how we could, how robotics is impacting the mission. So these two are very related.
Okay, so there's a new pre-certification program that is for devices only. It's just a little bit of a pilot because it's not there's some questions about the statutory authority to even use this model. So right now it's just in a piloting phase where FDA has selected several companies to work with them on how this would work in general. So I see it as kind of an extension of trying out third-party certification from a couple decades ago, but now the idea is, okay, so if a company is mainly just producing software, that's its medical product, can we trust that if they have good processes in place, that they're going to be good actors, that their software is going to be basically reliable and not hurt people unnecessarily? If something is detected as going wrong, they're going to take the initiative to fix it as fast as possible. Can we just basically leave a company like that alone to put things on the market and then just do whatever monitoring this group together is going to come up with as being an appropriate monitoring? But just to say there isn't an explicit statutory authority for this doesn't mean it's a no-go, because there have been a number of instances where, in the past, regulatory-wise, where the agency has done some pilot, and then that has persuaded Congress to give it a full explicit statutory authority. So right now that's just in the very beginning stages. And as far as using big data for pre-market applications for any kind of product, there is an initiative called real-world evidence, real-world data, and to me that's where the big data would come in, and that is still also in the beginning stages of trying to think about, well, when would we think that extending the current use of real-world data for supporting randomized clinical trials, that's been our current use for some applications. How are we going to depend on that more? And the agency just released a framework in the past month that talks about what FDA is already comfortable with, what questions they still want to work on for getting answers. And the National Academy of Science, Engineering, and Medicine has published a couple of workshops that are asking the same kind of questions. So they're all still in the beginning phases.
And even on the operational side, we're seeing robotics supporting the mission.
I'll jump in. Thank you. As you can tell from the panelists, there is no denial that AI is playing a role in our everyday lives, and it's growing. As a matter of fact, I would consider the prevalence and proliferation of AI, whether it be artificial intelligence as you know it, or more robotics automation, or RPA, it becomes part of our fabric. And from my perspective, and probably part of the message of this morning for me, especially in this audience who are all players within the AI environment, is that now that we're deploying AI, and even some of its attributes, the ancillary attributes like visualization, which is once you've got the data, how do you visualize it? All of these provide opportunities from an infrastructure and operational standpoint. Number one, as you see RPA being deployed in major applications, in my view, if you want to just step back a little bit, regardless of the technology, you're introducing somewhat of modular type of activities that have to be managed from a configuration and control standpoint. In other words, I change applications. I have a management process that makes sure, similar to interfaces. So as they proliferate, how am I making sure that my configurations are all still in place, that I've tested it appropriately, and that I can deploy it in a major production environment that have multiple systems, all potentially using these AI in different ways. So the calls, the APIs, all these things now in a proliferated standpoint, very, very similar to APIs. There are no control functions. There's no software tools out there that allow an operational group to manage it all. So it's pretty challenging and interesting, right? And then you also have the same idea that you've taken AI and personalized it. And now I can use some of these visualization tools, I can put them into an application or a data set, and I can start deriving information that may be a different look. The only problem is without good data management and governance, are we sure that we're seeing the data integrity? Is the same data element coming from this database comparable in terminology to this one over here, so I can make those kind of determinations? And AI can help us do that. But once again, these are the challenges from an infrastructure and support standpoint, especially with an organization 88,000 strong, like HHS, in all of our operating divisions. How do you put your arms around, number one, the proliferation and management of all of these technologies that are being introduced, and number two, how do we maintain data management and governance?
Thank you, that's great. One of the areas that is new and most exciting is around unstructured data in our health electronic records. And I'm curious from each of your opinions, how are you seeing different applications and pilots and use cases today that are really impacting disease and diagnostics and advances? We'll start with you, since.
Okay, sure. So some of the work that we've been focused on with our partners at Johns Hopkins Medicine is how to best leverage all the data that is now in the electronic health record, and how do we pull out useful data from the EHR and combine it with other data sets. So things like imaging, genomics data, all kinds of wearable data. How do we make use of the unstructured data that is in electronic health records? And so one of the approaches that we've been focused on is natural language processing. I'm sure lots of people are working in that space. But the focus that we've had is on generalizability. So of course we can develop an algorithm that looks to pull out one piece of data, and you can train it and you can get it working pretty well. But then can you take that same algorithm and with minimal customization have it work against a completely different data set? So for example, the work that we've been doing initially started out focused on prostate cancer. And it was simple things like, can I pull out PSA scores and Gleason scores from unstructured text in the notes section? And of course we went through and implemented that, but then the clinicians were so excited by the fact that they could have all of this data just automatically populated into other systems that the folks in multiple sclerosis said, well, we'd like some of that. So we started with the base algorithm, and within a couple of weeks we had it working really well against some of the parameters of critical importance to MS. So that's just one example, but I think across the board what we're focused on, and again, we're kind of an engineering organization, so we come at the problem from a slightly different perspective, but as we work with our partners on the medical side, how can we develop these algorithms and then have them generalizable beyond one specific disease or one specific condition.
Dr. Rucker?
Yeah. So it's always been an interesting tension between structured data and unstructured data. They have different uses. We are asked all the time as an agency about rules and standards around both of those things. It's worth understanding that if you want to structure data, you have to pay somebody to structure it if it's not coming from a machine. I think the big observation is that you can now actually look at documents as a whole, right? A lot of clinical medicine, right, or what are called notes. So if you look at the core data element, you have some of the machine-generated data, lab tests, images, and then you have this vast body of notes. And so there's two things we've been working on. One is just getting the notes so you can ingest them into a different system, something called the clinical document architecture. The other thing, if you actually look at the notes, what is not maybe immediately obvious if you're not in healthcare is most of the information in notes is actually templated nonsense. So the problem with notes is that they're largely geared as billing documents in America. And that means using a series of AMA, what are called CPT codes, Common Procedural Technology. So working heavily with CMS, we're starting to try to get this documentation to actually reflect what went on with a patient. This is going to be very important because under 21st century cures, and open APIs, you're actually going to have access to the notes And I'm sure you'd much rather read about something that has to do with you rather than a billing template that was put in on you and the last 1,000 patients and the next 1,000 patients. So there's an interesting NLP problem that's sort of lurking underneath, which is data quality, and of course that's true of all AI. So we're more on the data quality side because we want to enable this, and this is actually central to getting some handle on healthcare, because if you're going to look for value, we don't have a market economy. We don't buy our healthcare for ourselves for the most part. We have third parties do it. If you look at how do the third parties do it, it's this search for value. You have lots and lots of people in healthcare policy doing that. What data do they have? So that's really what we're talking about in terms of moving the ocean liner of American healthcare to something more responsive.
Great. So we've talked a little bit about opioid abuse, misuse, and the addiction issue that has become one of the biggest public health crises that we're facing today. It's also very personal for many people. And this requires really innovative approaches. So in May, the FDA launched an innovation challenge focused on advancing pain management devices. But all of you are involved in different challenges and activities and interfacing in your organization and with others. And I think it would be great for you to share more about how these challenges and new ways of doing business are impacting healthcare in your organization. And we'll start with the FDA that launched this initiative.
Okay, so that May initiative was one that was directed at device manufacturers, and are there things you can do to address the opioid crisis? So they selected 8 companies to work with to kind of expedite approval for them. And one of the ideas they picked wasn't really about pain management. It was about how to use the data to flag potentially dangerous opioid prescriptions. So it was fairly wide-ranging. The selectees have just been announced, so we'll see how their experiences are with going forward and working with FDA more closely. Now, I should say, every applicant is encouraged to work with FDA anyway. This challenge just put more of a highlight on that, but we're always telling potential applicants, work with us sooner rather than later, because we can work together to figure out what data you need to submit so that you don't go around generating data that you don't really need to and delay things, and so that you don't submit applications that are missing key pieces of information as far as our reviewers go. So we love having that opportunity.
So HHS, and I'm sure some of my colleagues participated, and probably a number of the people in the audience did, in a codeathon that was sponsored about a year ago in December. I think it was from our CTO organization, my sister organization or brother organization. The CIO and CTO sort of jointly facilitated a 2-day event that was all about bringing small businesses, large companies into a forum where people would have access to data sets and have access to systems. And we were looking to drive a change and some learnings through a codeathon. And I believe we ended up with 3 significant outcomes. I don't know how significant, but reasonable outcomes. One was one of the contestants that ended up being awarded created a heat map that highlighted 5 states where there were a significant number of mortality associated with overdoses. And this is over a 2-day period. The second group were able to identify a mechanism to allow clinics to create a drug return opportunity. So in those particular states, If we could reduce the amount of drug that was out there, i.e. unused pills, and create a channel for getting those brought back to the clinics and disposed of, that was another opportunity. The third was a physician dashboard in which physicians could in fact look at their prescription habits around the opioids and compare those prescription habits to the general prescription habits across the nation. So those were three areas in a 2-day period where technology and technologists got together and were able to make a quick impact on a very, very important area.
So I want to chime in on that. I observed the last hour and a half or so of that challenge, and I was there for the presentations of the top groups to become the actual winners. And I was struck by how many teams actually had a person on it who was impacted family or friend-wise. The level of passion was really gratifying.
I'd like to move to the audience for questions. We have time for a few. Raise your hand and we'll find you.
Excellent panel. I was wondering, what are current, I guess you say, challenges you guys are seeing that you wish AI or machine learning and different analytics teams would start going after that people currently aren't taking a chance to go after?
Well, I'll answer. I think one very interesting area that we're starting to look at a little bit in HHS, CMS, is as I was discussing, the sort of search for value. So right now, American clinical medicine is incented at the margins through something called quality measures, which are individual, essentially hand-curated metrics, right? And they're very expensive to collect. They're heavily gamed because you're paid on these metrics. So, and they're gameable and they're heavily gamed. And that's the proxy for value and quality of care. I think you can absolutely think about using AI to invert the entire information flow. So rather than doctors and hospitals sending these narrow quality measures to CMS or to private insurers, you could imagine a world using the APIs that are in progress where you reverse the information flow. You have the payers go directly to the electronic record endpoints, download for all the folks where you have a legal right, so everybody you're paying for, download some large set of the data, and then think about using machine learning algorithms to separate out not just who's, quote, better and who's, quote, not better, right? Not just rank ordering people, which is the current payment scheme, but actually identifying possibilities of taking better care of patients. It's a massive opportunity. There's probably all kinds of intermediate states to do it. So if you want a very gnarly goal, I'll throw that out.
Love it.
There may be, this might be a good lead into the next panel, but from an infrastructure standpoint, there's not only a lot of effort going on into self-healing networks and infrastructure through AI, which is predictive analytics saying this server will fail in this time frame based on the attributes that they're seeing in the patterns. And therefore, we can have self-healing networks which reduce your overall costs, and those dollars can move to the mission for opioid crises and things of that nature. But there's also another aspect where AI is being at least entertained, and that's in the cybersecurity realm. Right now, we're very reactive. We have breaches, we react. How AI, with the backdrop, if you're all familiar with the Continuous Diagnostics and Mitigation Program, CDM of DHS, which all of the federal government is a part of, HHS being one of the first of the federal agencies to fully deploy CDM phase 1, The promise there is to create an infrastructure where we can diagnose and mitigate, detect and mitigate cybersecurity threats. And I believe AI is going to play a major role in that ability to not only detect, but counter the bad players. So I think there's an opportunity there, and I think you have a whole discussion topic coming up on that.
I had many other questions, and go ahead.
Oh, please.
One more point.
So another area that I think all of us have heard about is physician dissatisfaction with their electronic health record system. There are a lot of people saying it adds time to their workday, it takes their attention away from their patients. I think coming up with a system where physicians feel like it's part of their right hand, is seamless, is useful for them, and not just the physicians, all the other staff that are involved with putting information in and trying to get information out. That is a huge challenge. I don't know how much AI would play a role in trying to figure out a system that's more user-friendly, but conceivably there could be, but at least it's a need, because until we get really good data that people are happy to put into the records, it's going to be harder to get the really important information out.
So I just want to sincerely thank all of you for your great insight and participating. Sounds like we have a few podcasts to line up for Molly, and I will let Michael transition.
Okay, absolutely. Well, thank you very much. Can we get a round of applause for our health panel? Thank you very much. All right, so we're going to give everybody a quick break, fill up on coffee, get a chance to network a little bit, talk to some of the great folks that are here. We got a great collection, like I said, of different agencies, different companies, as well as different academics. But please come back. We are going to have a great conversation here, presentation on what's going on with NASCAR, and then our national security panel. So we'll be back in about 5 minutes, everybody, all right? Oh, bathrooms are right around the corner. Over. All right, everybody. We're going to get back. We're going to kick back off here in about 2 minutes. So if everybody can get back to their seats, it'll be a big help. All right, 1 minute warning, everybody. If everybody could grab their seats again, we're going to kick off. Well, we are lucky enough to be joined here by Jamie Milne. He is the Big Data Manager with Worldwide Technology. And we're really excited to have him here, to have Worldwide Technology support with the program here. I mean, they're one of the leaders in artificial intelligence. And we wanted to invite Jamie here to the stage to talk a little bit about one of the use cases that Worldwide Technology is dealing with NASCAR, which I thought was really exciting. But also, I wanted to kind of talk a little bit about how Worldwide Technology is working with different government partners. So first, let me give a really brief introduction to Jamie. Jamie has a MS in astrophysics from University of Cambridge, which I thought was really interesting. And he worked with data coming off the James Clerk Maxwell Telescope in Hawaii. During your master's there, during your MS there. So I thought that was really interesting. I kind of geek out on space here and there. So Jamie, could you start off by talking a little bit about what WWT works with when it comes to government partnerships with big data in your big data manager role?
So thank you for the intro. We WWT is an end-to-end technology solutions provider. My group, my team is really focused on analytics and that kind of mission focus that Dr. Cott was talking about as well. We, previously we were the big data team. A couple of years ago, we were the AI team. Eventually, that's what we're talking about today. Tomorrow, it may be something else. We're really the analytics team. We focus on that mission. So we have folks who are really figuring out that mission, turning a mission problem or a mission challenge or objective into a math problem. We have folks who take that math problem and solve it. Your data scientists, whether they're using AI or traditional methods. And then we have folks who can enable that technology and kind of make it happen from an infrastructure perspective, leveraging, also it was mentioned with one of the panels, having that GPU technology or high-end storage and compute to be able to make that happen. We have the ability to not only come up with and figure out what the problems are, solve them in a mathematical way, but actually, deliver it and make it happen.
Okay. So when Jamie and I first talked a little bit about what we wanted to feature here at the event, it was kind of interesting. Quick background on me. Before I worked here, GovernmentCIO Media, I was an Air Force intelligence officer, and I kind of learned a little bit about what Jamie was working with a program that's connected to NASCAR. Now, I connect Air Force and NASCAR because when I was in the Air Force, especially in intelligence, they always said, hey, we want to be able to operate more like NASCAR or NFL when it comes to some of these big data issues. So I thought it'd be really interesting to talk about the program that they're dealing with Richard Petty Motorsports Group. So could you give a little introduction about how WWT and Richard Petty Motorsports are working together?
Yeah, absolutely. So WWT is a sponsor of RPM, and we're, my group and has been involved in that. We're very intellectually curious, and as we're getting as part of that partnership sponsorship model, we're figuring out how do they operate, what do they do. Turns out they've got a really kind of strict kind of supply chain business from testing, running practices all the way through race day. And like every organization, they're trying to consume as much data as possible, turn that into insights, and then ultimately use those insights to drive whatever strategy or whatever action they want to take that's going to ultimately give them the competitive advantage. So we worked with them. We wanted to figure out what their main pain points were. It turned out from an AI perspective, they were taking a lot of race imagery, a lot of high-resolution images of the race, and that comes to them in a very rudimentary fashion. It's just all imagery that's taken centrally by NASCAR is dumped in folders somewhere for someone to go out and look at. And I'll set myself up for failure by defining AI kind of off the bat, right? But one of the ways to look at AI is how to replicate human decision making, but using a computer. So what we were taking was trying to automate that process from they only have a very small pit crew whose job it is to make sure that the race is going well, but also setting up the race as part of that supply chain. And a significant amount of time and effort and people is spent combing through these photos, trying to figure out, okay, where do I identify the car? Then they're looking for the car themselves. They're looking at, okay, am I hitting the corners correctly? Yeah. Where am I in respect to my competitors? What kind of damage can I see in the cars? Any other things that you can see visually from this high-res image? So we're able to use AI and some neural networks to identify automatically where the car was in those images, and provide the folks on the team, okay, here are the images that you have, and now you can look at them and figure out where they are. Next steps is really to zone in, now that we've identified those images, is to identify where the anomalies are, whether that's anomalies, again, going back to the mission is to make sure the car is operating mechanically well. So looking see if you can identify those faults or any issues. Make sure the cars are being driven in the right way. So see where they're positioning on the track and things like that. So we're using AI and enhanced and deep learning to figure out that and automate that. So it's with a lot of these things, it's really augmenting of the manual process. So the folks are. Ultimately, these folks who are working for NASCAR are at the top of their game, are incredible analysts at figuring out what needs to be done, but they spend 60 to 80% doing the admin of going out the data and rationalizing it in their mind. And that's the same across any organization, whether it's commercial or federal. A lot of work, we have these, myself internally, our team has these fantastic data scientists who do incredible work, but they spend 80% of their time, wading through data, trying to get the definitions right, trying to combine these data sets, and that's exactly what we're doing, but in the race setting.
And that's what I thought when you guys were explaining the program. I thought back to my time of having so many of these Air Force imagery analysts looking at imagery sets coming in from, the collections from like the Predators or the Reapers and whatnot, and it just seemed to me that it just was a complete connection there, where the same way that those folks were looking at imagery from the races, and making them more efficient, making it a lot easier. I think there was a statistic where the Air Force was saying that they were only looking at about 6 to 7% of the actual intelligence that was coming in, because humans can only look at so much there. But with like a system like this, it seems like that number can skyrocket quickly. So I think that's really interesting.
Absolutely. It's about getting them the right information to the right people as quickly as possible. You could say that, that the healthcare panel here as well, I heard that your average radiologist looks at an image every 8 seconds to figure that out. So if you can get that person, whether it's a radiologist or an Air Force analyst or a NASCAR pit team, if you can get them the right images faster, or maybe draw their attention to any anomalies or specific areas of that image that quicker, that's going to save them, it's just going to save them a ton of time, make them more effective, and maybe even make it a little bit more risk-proof as well.
Out of the program, and when you were coming to some of the conclusions from it, were there any results that really stood out to you?
There were a couple of cool things. Number one, just seeing it at the race day. That's one of the benefits of being the sponsors. Everyone is scrambling to get there. We're in the pit itself. It's just a really neat thing. But seeing the results, seeing the we also did a lot of UI work for them. So they're using this dashboard, but you can literally see the folks previously who were combing through Dropbox folders looking for files, are just having these images pop up, and they're making decisions based on the work that we've done. You can see that and kind of touch it and figure out that benefit. A couple of the geekier things, or I would say cooler things, we, as part of the work itself, our data scientists are really lazy. Like that's a really good. There's a Bill Gates quote, I think, about how he doesn't hire smart people; he hires lazy people. Because a smart person will figure out, right? Going back to the point again on the mission, smart person will try and figure out all the complicated ways to do it. A lazy person will figure out how to get their job done easier.
So which one are you?
I'm very lazy. So we have these data scientists. A big challenge for image analysis or any unstructured analysis really is tagging of the data. So okay, if I'm looking at this image, I know that that's car number 43 was the one we're looking for. Or if I know, for a radiologist, right, I know that this is a particular, whatever type of medical anomaly you're looking for, or for an Air Force person, this is what a missile silo looks like. There pretty much always has to be some human input there. So what we did that was really cool was we created our own app to tag the data manually ourselves. Okay. And we produced it in a way that we were showing, we ran a kind of preliminary model, which was very rough and basic, but would provide hundreds of images on the screen and allowed our folks, myself included, we kind of crowdsourced it as a team to find where the model was getting it wrong or not. Okay. So we were able to tag hundreds of images at one time, find the anomalies, click through, keep doing it, and once you do that kind of reinforcement learning, that really strengthens the model and makes it faster. But that was a cool kind of application we developed, because a lot of folks that we're seeing maybe want to do that, want to do image analysis, but don't necessarily have those targets or those tags that you really need to be able to do that. So that's kind of a shortcut that we would be applicable across any space that we enjoy doing. So that was a neat kind of time saver for our team, and got us very excited about that. Another piece was this was more fun stuff, or I guess R&D, if you want to be super corporate about it. Right. But we used GANs, so adversarial networks, to create dummy data out of the NASCAR imagery file. So we took the 10,000 NASCAR images and used this new kind of completely new, but it seems to be rising in prominence very quickly. Use this GAN algorithm to create dummy data based on the NASCAR data. So actually, you can multiply your data set and provide yourself with more training to be able to run that. Another, some interesting industry implications for that is, it works on imagery very well. So you're basically taking an image set, creating new images that look very similar to the other data, but they're not. They're just dummy data. But that's got a lot of implications for PII, for sensitive information, where if you want to leverage commercial data scientists, or you want to leverage other folks who either aren't cleared for that data, or you want to host it in a platform that's not secured, right? Obviously, security is a big focus in the government space for lots of very valid reasons. But we're starting to use these networks that create this dummy data in an intelligent way, using that sensitive data.
Okay.
So we can now have folks either use it for testing of infrastructure in our lab, or we can have our data scientists who maybe aren't cleared or haven't got whatever reason to look at that data, or just because, frankly, it's quicker to do that, right? If you're using dummy data, you can get approval very easily. If you want to use PII data, you have to go through all these formalities. So that was a cool thing. Discovering and getting to play around with that kind of technique has really opened up a lot of doors for us to kind of cut the red tape of this kind of AI processing, because there are all those ethical questions, and thinking about how the machine interprets or how it disseminates that information kind of hopefully becomes a little bit of a kind of shortcut to be able to do that.
Okay. Well, thank you very much, Jamie, for sharing a little bit about the NASCAR program and what you guys are doing with Worldwide Technology. I think it's a perfect transition to our next panel here, and our final panel of the day, the National Security Panel. I think, Amanda, you're doing this one, right? All right. So can I introduce Amanda Ziada, our reporter with GovernmentCIO Media and Research, to the stage here. And she will be joined with our... So thank you again to Jamie for joining us, and I'll hand it off.
Hello. Good morning. I'm very excited to close out our event with our National Security Panel. My name is Amanda Ziada, reporter with GovernmentCIO Media. Just two quick notes. Please continue hashtagging CXO Tech Forum on social media for our last panel, and we will have time for networking right after this panel. So if we can keep conversation in the back to a minimum, that would be wonderful. All right. All right, so let me introduce our panel. To my right, we have Mike Olson, Chief Strategy Officer of Cloudera. Next to Mike is Todd Myers, Automation Lead at NGA. And next to Todd is Mike Madsen, Director of Strategic Engagement at DIU. So I'd like to start by briefly asking each of you to give the audience a little rundown of what your position entails in your organization. We'll start with you, Mr. Olson.
I co-founded the company 10 years ago. I am an unrepentant nerd, so I grew up as an engineer. But my major job now is talking to our customers and partners about how they can apply our technology. I'm much more a sales asset than a technical asset at this point.
Todd Myers. So I'm focused on automation to accelerate how we deploy large-scale capabilities that are focused on distributed processing for large overhead imagery, as well as machine learning type of technologies and techniques. Lately, we're focused on distributing our clusters between three environments, what we call high side, SIPR, and the low side .mil environment, all residing on Amazon Web Services.
Good morning, Mike Madsen. I'm the Director of Strategic Engagement for the Defense Innovation Unit. We are headquartered in Silicon Valley with an outpost in Austin and Boston, but I drew the short straw, so I'm stationed in the Pentagon. DIU leverages commercial technology to solve DoD problems. So my job in strategic engagement is to work with all the stakeholders in the Pentagon, as well as on the Hill, and working with commercial industry, technology companies, as well as venture capital firms.
All right, so quick overview question. What potential does AI have on improving or enhancing national security?
We work with a number of parties in the defense and intelligence sector. but don't generally talk about the workloads they're running. What I can do is talk about germane workload from the commercial sector that I think is instructive. So if you are a bank, you're required by regulators to know who your customer is and to watch for patterns of money laundering. And it turns out if you're able to collect a lot of data about the networks of people that are doing business with one another and the patterns of money moving among them over time, that is highly instructive. That's a really useful thing to be able to do. And machine learning is a technique for analyzing patterns of activity in that network over time. And if you're a bank, you also want to know if your traders are engaging in self-dealing, or if you're a regulator, you want to know if traders at different banks are manipulating the markets and prices. And therefore, communications among folks are collected, phone calls recorded and turned into text. The contents of those comms are evaluated for messaging among people. Different algorithms apply in all of those cases. So spatiotemporal activity in a graph, that's one machine learning model on one kind of data. Speech to text, that's another machine learning model on another kind of data. The natural language processing on the text data is something else altogether. But combining those models into algorithms that look for patterns of activity and content of communications turns out to be hugely helpful in pursuing those important missions in the financial sector. And you can imagine really good analogs of those in defense and intel.
What Mike said. So we're exercising very steadfast of applying techniques and technology, using technologies to build a corpus that we can execute machine learning against. And that's going to take some time. We have a lot of data. And we have a lot of data that has to be, have algorithms written in the context of trained data sets. So I wouldn't say that we have majority of lessons learned from AI. I wouldn't even say AI. So we're really focused on making sure that the core of what we're doing from a machine learning perspective has the integrity and then has the provenance to follow that to then execute AI.
Mr. Mattson?
What these two gentlemen said. Just kidding. Many of us have heard and used the OODA loop, observe, orient, decide, and then act. From the Defense Department mission set, we use the OODA loop, and to defeat would-be adversaries, we need to operate faster than adversaries are operating within the turn radius of their OODA loop. But in today's fast-paced world, fast-moving data, we talk about information dominance, information superiority, those type of things. The same way we talk about air superiority and air supremacy in a battle space. But I don't know that information dominance is always going to be doable, and so it really becomes a temporal advantage type of situation. And sometimes that temporal advantage might be enough for the Department of Defense warfighters to remain inside the OODA loop turn radius of our adversaries. And that's where artificial intelligence and machine learning comes into play. The ability to accelerate through that observe and orient steps in the OODA loop to remain ahead of our adversaries. And the situation I just described is a warfighter mission set, but that would also apply to humanitarian assistance and disaster relief as well.
So, Mr. Myers or Mr. Mattson, do you have use cases or projects in the works right now involving machine learning, artificial intelligence, deep learning?
Yes.
Can you talk about those projects?
Perhaps. So we do. We have orders of 10 to 20 to 30 terabytes to 50. You can guess a size of data that's being ingested. It's being ingested, and we're applying machine learning algorithms that have been developed specifically using container technologies such as Docker and Kubernetes and Mesos orchestration. That is the mean by which we are able to harness the algorithms and orchestrate them against a swath of this volume of data. That's only the beginning stages, and from that beginning stage, we've been able to generate automated machine detections, right? That's only the beginning stage. You have a detection, now what do you do with it? Now I need to put it into an edge node graph environment so that I can start seeing clusters of activities, right? So there's taking a lot of the data that we're doing now and bringing it into an environment that has been normalized using what I call primitives, primitives that are exactly that you would find in a Facebook data center or an Apple data center or a data center from Wells Fargo. that massively focuses on the correlation of distributed analytics based upon orchestrated container topologies. I didn't say the word system, I didn't say the word transition, I didn't say the word integrate. And the reason I didn't say those words is that those don't have applicability in this language of machine learning. So we're focusing on iterating, failing hard, fast, and bringing in this data so that we can apply whatever algorithm data scientists comes up with, or evoke or bring in code via code pipelines that allows academia or industry or other government organization or the services to have their code come into our environment, to our pipelines. We do a build process and we lay the container and algorithms on the clusters, and then we ingest the data and do that processing. So we are doing this from an extensive standpoint. This is only over the past 2 years, and there's a lot to be learned.
We have one project that we're particularly excited about, and that is for the potential that it can scale across services as well as platforms, and that's using AI and machine learning for predictive maintenance. We partnered with the Air Force and took one airframe platform and ingested about 7 years worth of data. And by the way, the aircraft maintenance world, they collect huge amounts of data that they're just now learning how to manipulate this for things like predictive maintenance. So we took all that data and ingested it, and what we found was that a reportable return of about 30% reduction in unscheduled maintenance for aircraft. Now on the surface you're thinking, all right, 30%, that's all right, about a third, no big deal. But let me put it in context with a quick story. In a previous life, I was a C-17 pilot, and I can recall 2 specific missions. One of them was a warfighter support mission, and one of them was a humanitarian airlift mission, where we departed home station, got to an austere airfield halfway around the world, and upon landing we broke. We could not take off again. So we had to call back, and Mother AMC had to generate a part, figure out what was wrong, send the part halfway around the world, send a maintenance technician halfway around the world to repair this. And it took about 5 days for that. So while that's going on, our warfighter mission and humanitarian mission were both delayed. So there's a humongous cost savings here, because if we would have had that AI, ML, predictive maintenance, we would have known the part was going to break before we left home station, and we could have fixed it there. So there's some cost savings there. AMC, Air Mobility Command, had to generate 2 more missions to go do the mission that we couldn't do because we were stranded halfway around the world. And there was a delay getting goods to the humanitarian effort as well as supplies to the warfighter. So we're talking about time saved, money saved, as well as lives saved, most importantly. And then a side note of particular interest is the increased maintenance reliability rate. So again, like I said, this is something we're very excited about, scaling across aircraft platforms in the Air Force, but also the Army just signed a contract for predictive maintenance on their Bradley fighting vehicle. And the Marine Corps just called me the other day. They want to look at applying predictive maintenance to some of their vehicles also. So there's an opportunity to scale across platforms as well as the services.
Okay, and I do want to talk about the challenges you're facing in these projects, but first I want to ask Mr. Olson, with your experience working with the national security and IC community, where do these agencies need to start or build a foundation for these kinds of AI and machine learning technologies?
Unsurprisingly, these agencies are already pretty sophisticated. So they've got smart mathematicians and technologists who have been using these technologies for a while. As the tech gets better, it applies to more of the mission, more workloads, more use cases, and so on. What we see, not just in government, but broadly across our customer base in the commercial sector as well, is taking advantage of technology in new ways is as much an organizational and cultural challenge as it is a tech challenge. So decision makers often don't pay attention to computers. They often pay attention to paper. The recommendations that can come out of a predictive maintenance system, for example, need to be acted on now, right? It's no good to know that 2 weeks ago I should have fixed the Bradley fighting vehicle. I need to know it right now. And that means the people in the decision chain need to take advantage of these tools while the information is still fresh and useful. And that is a real cultural difficulty. You guys heard about the guy in Japan who was named Minister of Cybersecurity who didn't even use email. Now, it ain't that bad in government, but sometimes there are people who are a little bit allergic to computers. And providing them with appropriate tooling and making sure that they're taking advice from the machines and making better decisions as a result, that requires cultural and organizational change as well.
Are you faced with these changes in these projects?
That's kind of what we do. Before I was with DIU, I was the executive director of a congressional advisory panel for acquisition reform. One of the things we looked at was small businesses, because that's where the innovation occurred based on patents that were awarded. And I understand that invention and innovation are two separate things, but really it becomes a non-traditional company. And I only bring up that previous job because what we tried to do there was illuminate a pathway to the defense marketplace and lowering the barriers to the defense marketplace to some of these non-traditional companies where the tech is. And so fast forward, that's natural fit working for DIU. That's what we represent, a pathway to the defense marketplace to leverage the commercial technology that's out there to solve some of DoD's challenging problems.
Do you face any challenges, Todd?
So I don't view them as challenges, I just view them as concise direction. So I have a concerted effort under my activity with my team that we're bringing the ownership in on my team to deliver from the government out, and which is converse to a lot of the way things are done, right? So I don't put a description of a document out and then have somebody bid on it, and they develop it in a factory. That's the term we use. And then they throw it over the fence to us, and we figure out where to put it in place. We put the development efforts inside of the government space. And what we're developing is actually going GFE for the government to use. And oh, by the way, we've open sourced it as well. Our activity is on NGA GeoInt GitHub, or GitHub NGA GeoInt, and you can look it up, and I'm sure you can find out the information later on. And we're doing this for a reason, and primarily is that we wanted to revitalize the skill set and the ownership from the government perspective of having government federal employees that can code, that can develop, that know about 12-factor wrap, that know their history, a little bit of their history of what it meant when Alan Turing was programming into what it's been today. There's context there, and it's been completely lost. And you don't get that by buying AI, ML from a company. You get that from developers in government taking ownership and developing against context for mission relevancy. So all of what we've been focusing on the past 2 years through several efforts has been to harness the technology, to deploy our capabilities in a provider environment. Some of it's bare metal, but most of it's going to be a provider environment, such as Amazon, to engage with industry and outreach, such as what this mic referred to as out in the valley, outpost environments, but to bring that code into the government space so the government can develop and own it and participate and be part of that solution set. So I don't view it as a challenge. I view it as a very concise direction to take ownership back in the government space.
Can I actually add on to that? Mm-hmm. I think you bring up a really good point, and part of it is culture and bringing that back into the government space. And I'll use an example of the Air Force. When I was on active duty, there was a one sheet that summarized everybody's career. And the Air Force admin folks could search by name who in the Air Force spoke Russian, who in the Air Force spoke Spanish. And in fact, they paid folks to maintain that currency. And they just recently started doing that for things like Python. So now they can search and say and find out by name who speaks Python, which is a coding language, that they might learn in their spare time that their actual job is sweeping the floor underneath the missile in some missile range. But they're starting to track those things to pull those capabilities back into the services, and that's very encouraging to see.
All right, so I want to shift gears a little bit to the ethical concerns of using AI in national security. Obviously, we talked about the benefits, cost saving, life saving, improving efficiency. But a few months ago, earlier this year, Google announced that they will not renew its contract with the DoD's Project Maven after some employees expressed concern over using AI for this mission. We're not going to get into that particular event, but I just wanted to ask, is this a concern in the national security community? And if so, how are you dealing with it? No. Crickets? Other ethical concerns of AI?
I'm glad to go first. Yeah, huge. And this is a super knotty problem. We built our company. We were the first player in the space to commercialize some technology called Hadoop. This is big data software, and the ecosystem has advanced a lot. There's much better algorithms. We're doing a lot of really cool stuff. But fundamental observation, this stuff was born for surveillance. That's why big data technology emerged in the consumer internet. And it turns out to be hugely useful for watching large populations of people. I talked about some use cases a minute ago. We're a liberal democracy with a fundamental commitment to human rights. And in general, our defense and intelligence apparatus has been stalwart in defense of all of that. We need as a society to think about the ethical implications of the technologies that we built and how in defense and intel we apply them while preserving our democratic and human rights commitments. You all know that China has invented something now called the social credit score, where they surveil all of their citizens all the time, pay attention to their political statements online, their patterns of shopping, and decisions are made like where those people are allowed to live and what kinds of jobs they're allowed to. Now that is deeply offensive to most Americans that we talk to, but it's a different society operating on different premises. When you think about development of the technologies that we're talking about here, machine learning, we apply them and we think about their application in ways different than our adversaries do. It is an uneven playing field, and we don't have control over the means of production. That is, advances in AI are happening worldwide right now. How we thread the needle, how we think about behaving ethically ourselves while confronting different ethical frameworks and pretty serious bad guys, it's going to be tough. It's going to be tough. One last point, and I won't go into details, but look, I thought when the Snowden revelation happened, at least we might have a full-throated public discussion about ethics of data collection and use. Didn't happen. A whole bunch of other breaches and leaks have happened in the days since. In fact, I picked on the Chinese a minute ago. It turns out the Chinese were responsible for the theft of data from Marriott recently. I really do think that a global society, and certainly American society, needs to debate what is right. In the meantime, I really don't think I need my hotel collecting my Social Security number.
I think it's just a hype. You know, if we did a data call of the percentage of DoD IC systems that are actually mature enough to actually threaten what that question is inferring, it would be laughable. Because the majority of these systems are legacy designed. There's no AI, there's no ML. It's controlled system interfaces, right? Serial command and control type of activities. The question is poking at the hysteria notion that the machines are doing something nefarious. There's no concern.
Can I push just a little bit? Granted, there's a lot of legacy technology out there. Don't we have a responsibility to formulate policy and to create legislation supporting it that dictates how we will apply these technologies in support of our ideals? Don't you think that that's an important thing to do?
I completely agree, but I think that the amount of time that we need to take to mature our approach, how we govern, how we establish the approach to govern with well-informed individuals that know how to compose and use a microservices architecture, and the meaning of what ML really needs to do and what the train label data sets need to be. That's why I really have no issue saying I don't have a concern right now. I think it's overly hyped in the private sector based upon examples that are out in ungoverned, vetted environments in private industry, some of which in other foreign nations. I don't think it's applicable to the U.S., and I don't definitely know that it's not applicable to DoD and IC.
I think we all want AI to be like Ender's Game or maybe what's depicted in iRobot, and it's probably currently more accurately compared to, say, Pong from the 80s. Some of you out there are not laughing because you don't know what it is, so you have to Google it. But I think that you know, it may get there someday. So, and now in this early stage is the time to start addressing those issues. We've experienced no reduction in folks that want to work with us in the Valley. In fact, we have more and more tech companies that do want to work with us because we represent a challenging mission set for them. And let's face it, entrepreneurs love a sticky challenge. But I think the ethical issue is also a sticky challenge that's not a DoD problem or a whole of government problem, but a whole of society problem. And we want as many folks involved in that national debate as possible. To come up and solve that. The Defense Innovation Board has been charged to come up with AI principles of defense, which I think is a great start for that, bringing in some folks from the academic world, the industry, and defense to start framing out what this looks like.
Be clear, I agree with Mike entirely. I'm not concerned about the national security apparatus uniquely. We have a broad social challenge in front of us as to how we apply these technologies. I will say that in our experience, our government clients have been absolutely stellar at paying attention to the laws that apply to them.
So maybe we can agree that there should be some sort of AI ethical guideline, regulation, policy developed to help with these challenges in the future as we progress with this technology. Would that help?
Well, I think it certainly needs to be part of the national debate.
Mm-hmm.
Yeah, I absolutely think so. We have a blunt instrument that we've applied in the past to technology, export control, that we've tried to use to contain how this tech gets applied by the bad guys. I don't think we have that possibility here. I think that the techniques and the mathematical skills are global. For sure, in the U.S. and in the commercial sector especially, we need better ethical policy and control. How we think about that globally, that's going to be hot. That's going to be tough.
Okay. Next topic. Todd, I wanted to talk a little bit about your deployment of a multi-data center and cloud processing clusters for NGA. You're using machine learning and deep learning for that, and we talked about the challenge of scalability. Can you explain that a little bit?
Sure. So we've taken advantage of machines that are easy to spin up, and we've laid a orchestrator on top of that. It's an open source activity, Mesos and containers and whatnot, Kubernetes, etc. I don't really have a favorite one, but we do have a direction, and the direction is that we didn't want to go down the path of being bound by an environment that dictates how we write an API or interact with an API. So we wanted to make sure that wherever we deployed, we could focus on the transportability to evoke algorithms, mission data pipelines, to ingest mass amount of data, to index mass amount of data, to run ultimately hundreds of thousands of algorithms, whether the data comes in and it's a Kafka stream and an event and topic and then runs through Spark. I need to run NIDF extraction, which is information about the metadata that tells us information about the image file, and whether we need to extract run out other algorithms to extract more information to do detection. These are all going to happen, right? This happens today. I rode the metro in, and as I'm riding the metro, it's giving me spatial temporal information, and that's being referenced on a map, and it's being referenced on a map based upon a correlated detection, based upon data that's stored, I guess it was a Google map, that's being streamed back to me. So the approach is to don't think about system designs, because system designs require a static definition of design state. Think of things that live for a second, they do their job, and then they move on. So our activity is focused primarily on establishing what we call core, and core has technologies and techniques and process that allows us to insert, like a Lego block, any technology or any process that follows these principles. And the principles are very simple. It's extremely simple, and it's ironic that we're talking about machine learning and AI, but the principles that's going to greatly enable this is based upon three things, three simple things. Code to source, source to a pipeline, pipeline to delivery of evocation in a container namespace. It's that simple. And if you scale that and you focus on that deployment model, no matter what you want to evoke or what you want to work on, whether it's a stateful or stateless application, it can be managed. Now here's the challenge. The amount of activities or organizations that understand what I just said, that can comprehend what's required to do in their organization to remove all of the system designs and bring in a fabric of orchestrated microservices based upon container topology is foreign. It is not the norm. So if we're actually going to harness machine learning and AI to go forward and ingest mass amounts of data and have correlated analytics that have meaning, then we have to normalize these environments. And so that's what we focused on. We focused on developing a core. The core will use the technologies of the day. The core will be deployed in cloud environments. The core will be deployed in other environments, bare metal, other activities. But we won't focus on deploying a system that does one thing, right? So we need to be flexible. So by doing that over the past 2 years, we've successfully been able to ingest major overhead data at a scale that's never been done before, at a cost that's orders of magnitude so absurd I won't even tell you the number, less. And we've greatly enabled the developers to iterate and fail hard fast against their code. So when we bring in an activity or capability, we do component testing, blue-green deployments, just like Facebook and just like Apple, just like Twitter does today. There's no difference. There's no need to reinvent them. We have Scrum Masters and we have activities that focus on gathering user stories and following the principles of Agile methodology and so on and so forth. All of that is all part of this process, and all that requires an investment of the organizations to understand you just don't go out and buy this. You actually have to own this. You have to be participating, and you have to make others become participants as you go forward. So by doing this, we've greatly transformed the legacy systems of it did one thing, and now it's just a blank slate, so to speak, a canvas that people can create as they want to. They can bring in data, they can write their algorithms, and they are able to control their destiny to some degree, and they're able to share that data and those analytics at a much bigger scale.
All right, so I want to close by asking, Mr. Mattson, we talked earlier about how DIU changed the business model to focus more on DoD's mission rather than the new technologies out there. And Todd, along with what you were saying about the techniques used and not reinventing the wheel, how can government and industry work together going forward to properly implement AI and the technologies it brings efficiently?
Well, I think the first thing is we need to focus on fundamental research. We need to make it easier to do business with the government. I mean, let's face it, it takes large muscle movements to do business with the government and DoD for sure, which is what we do in DIU. And then I think we need to reinvest in ourselves, increasing STEM education. So what we do is you alluded to our business model, we look for a DoD partner with a challenging DoD problem, and then we help them curate it and make sure it's not a list of requirements, not a description of a symptom of the problem, but the actual problem. And we're looking for a short statement, half a page, a paragraph. I think our shortest is one sentence. There's a run-on sentence, but one sentence nonetheless. And then we push that out to the tech industry and get solicitations on how they think they can solve that problem. And then we work as a facilitator between the Department of Defense partner and the tech company to come to a resolution on what that looks like, and we look to award a prototype contract within 60 days. We're averaging a little bit higher than that right now, but our goal is right at 60 days awarding a prototype contract. And then we look to field that technology within 24 months, so it's fairly rapid. And we have a lot of authorities granted by Congress to rapidly acquire things. We need to, again, make it easier to do business with the Department of Defense. The other thing we need to do is increase the national security innovation base, and that's one of our other things that we're looking to do by reaching out to a lot of tech companies. Getting back to the triangle that really birthed Silicon Valley back in the 70s, that triangle of industry, government, and the academic world, we really need to get back to that and build that national security innovation base.
I'll close the way that they began, what they said. Both Mike and Todd have talked about agility and speed and organizing for embracing the technology in support of the mission. All that's fantastic. The only thing I'll say from industry's point of view is that while government needs to get maybe a little bit more agile, at least in the large, industry players who want to work in this space need to take very seriously their obligations, right? And a lot of dinky little Silicon Valley companies are willing to tolerate failure, downtime, security issues in the commercial sector that simply can't be tolerated in this space. So I think that those of us in the Valley could take a lesson from some of our colleagues on this coast as well about the importance of reliable, robust, and bulletproof systems.
Did you say you were going to close? Can I add one more thing? So I have an extremely high expectation. I have a barrier to entry of how industry or developers work with our expectations. And because the stuff that we're doing, there's no error ratio. It has to be on target. The detection has to be a detection. It can't be, oh, well, we were close, right? And so my bar is extremely high like Uber high, where you expect to get in an Uber and you expect to give your location you want to go and you expect that car to go there, right? There's a lot of data that's being processed to provide what looks like a really simple app. But that bar is extremely high. And right now, we're nowhere close to that bar. So there's a lot that industry and government on both sides can get to that bar. And it requires all of what we just talked about, plus understanding that the days of designing a system to sell to the government are gone. The days of iterating capabilities that can fit into distributed architecture are here to stay. So the more you interact at that level, the greater opportunity becomes for everybody in this room and the government to receive.
Can I add one more thing?
Sure.
So in this area of great power competition, we are in a tech race. And it's not just for the technology we're talking about, the foundational technology, AI, autonomy, robotics, cyber, those type of things. AI certainly is one of the most important. But it's not just winning that race. If we lose that race, we will exponentially lose the race for all the future applications and products that spring from that.
Okay, I don't think we have time for Q&A, but we do have a networking break after this, so hopefully you can catch one of them after. Thank you guys so much for joining me today. Really appreciate it.
Thank you.
Okay. All right. Well, thank you very much. That's our final panel for the day. Thank you, everybody, for joining us today. What a great selection of speakers. So can we get one more round of applause for all the speakers today? Excellent. So before you go, our next event, our next CXO Tech Forum is February 21st. It's going to be Uncle Sam meets Silicon Valley. So it's going to be a really exciting group of speakers here working on a lot of the innovation projects that the government's pursuing on industry as well as the government. So hopefully you can join us then. But yes, please subscribe to our newsletter. Take a look at our podcast. There's a lot of ways to engage with us. But thank you again for coming, and we will see you soon.